welcome to our channel. Welcome. We are about to do some mathematics. We have a beautiful question I want us to work on this video. Okay, let me start with the defining statement. The first statement says the function of x, f of x, is equals to minus x minus 2x squared plus 2. This is a parabola. It's a quadratic function. You see it by the power of 2. It's a quadratic. And the g of x is equal to 2 to the power of x plus 1. This is an exponential function. You see it by 2 raised to the exponent of x. At the defining equations of graphs g, I would say f and g respectively. Okay. The first question says write the asymptote of g. G is an exponential function. G is equal to 2x plus 1. So we know that an exponential function is defined by y is equals to abx plus 1. So where, let me say plus c, where c this c, where this c is an asymptote. Which asymptote? The horizontal one. The horizontal asymptote, to be specific. The asymptote for an exponential function is in this form. So we are required to write down an equation for the asymptote of g. 4.1. So they just say you must write, you mustn't calculate or anything. So since I said this is the horizontal asymptote, here's the asymptote. Here's our asymptote that we are looking for. So the asymptote is going to be y is equals to, since it is a horizontal asymptote, it's y equals to 1. Sketch the graphs of f and g on the same set of axes, clearly showing the intercepts, with the axis, turning points, asymptotes. Okay, so let me start by writing my function f of x and my other function here. Then I want to separate them. Let me separate them. Now they're separated. Now we're going to first work on f of x, then after we're going to work on g of f. So they said we must get the intercept. the intercepts. Since we are working with the XY plane, so it means we're gonna be concerned with the y-intercept and the x-intercept. So to get the x-intercept, y is equals to 0. On the x-intercept, y is equal to 0. So where y is equal to 0, it means that the function is equal to 0. Okay, so now I can divide the whole equation. I can divide everywhere by -2 because of I just don't want this negative. Yeah, x squared minus y. So adding 1 on both sides will remain with x squared is equals to y. So x is gonna be equals to plus minus the square root of y. So x is equals to 1 or x is equals to, okay, -1. So these are the x-intercepts. The x-intercepts of f of x. So it is good because if we got the two x-intercepts, when you are working with a quadratic function, at maximum we can get two x-intercepts at maximum. So now we're about to get the y-intercept. The y-intercept. Okay, I think, okay, the y-intercepts. Y-intercept. So for the y-intercept, x is equals to 0 because of what? The y-intercept is on the y-axis. On the y-axis, x is equals to 0. So it means we have to get where the function, where the x value of the function is 0. So the y-intercept is equals to 2. We got it. Now we are done with f of x. I mean, say with the intercepts, we can now check them. We need the turning points, and asymptotes. The parabola doesn't have any. The parabola doesn't have any. This parabola doesn't have any asymptotes. Okay. Now let's look for the turning point. To get the turning point, since we already know okay, the x-coordinate of the turning point, TP is equals to x of root 1 plus x of root 2 the roots I'm talking about, the intercepts, all divided by 2, it's equals to, we know that one of the roots is -1, the other one is 1 divided by 2, so is equals to 0. Or I can say axis of symmetry is equal to minus b over 2a is equals to, let me go back to the function. Our b value, I think it's 0. Let's go back to the function. I want to show you how to get the b. So the parabola is in the form y is equal to ax squared plus bx plus c. So here's the b. So it means here the b, because of this the c, because of the c is the constant, it means the b is equal to 0x. So let's go down. Then our a is -2. Now let's go down to write our work. Here's the formula you use to get the axis of symmetry. The axis of symmetry is the same as the x value of the turning point. So we have 0 over 2 minus 2. So it's the same as 0. So the y coordinate, I mean the x coordinate of the turning point is 0. But we know something very interesting. Something interesting is that at 0, the y is 2. So this means that the y-intercept and the turning point are the same. This means the y-intercept and the turning point are the same. It means y-intercept wrong spelling, is close to turning point. Okay, not turning point. It's called to the y coordinate of turning point. Nice. Okay. Interesting information. So now with all this information that we have, we can go down to draw the parabola. Then we will come back to the exponential function. Let's go down and draw our function. Let's go down and draw our function. We're gonna draw them on the same set of axes. This is the x-axis. This is the y-axis. Okay, good. This is the y, this is the x. So we know that one of our x we know that our turning point is at 0 and 2, and we know that our other x-intercept is at -1. Our other one is at 1. Where am I? Bad draw. Okay, let me just do the free sketch, then after I'll do the coordinates. Oh, this is bad. I don't really like doing this. Parabola doesn't look right. Yo, here's at -1. It's at negative the coordinate. Okay, let me write it in coordinate form. It's -1 and 0. Here it's 1 and 0. Here's the turning point, but it doesn't look like 1. But let me try to make it look like 1. The turning point is where it's turning. It's at 0 and 2. So we're done with our parabola. We're done with our parabola. Now we want to draw our exponential function. Let's go up and draw our exponential function. Okay, now let's draw our exponential function. The first thing that we know about the exponential function that we already wrote is that the, the asymptote is y is equal to 1, the horizontal asymptote. So now we want the intercepts. Let's start with the x-intercept. So for the x-intercept is where y is equal to 0. So you see that -1 cannot be equivalent to 2x, so this cannot be. So it means we do not an x-intercept. Yeah, we don't have an x-intercept. Sorry for being quiet for a while. I just had something disturbing on my side. Sorry guys. And now we are looking for the y-intercept. So y-intercept is 2. So now we can go down to draw our lovely graph. The first thing that we know is that let's write down the asymptote. Okay. My lines are not straight at all. Yo, they're very skewed. I don't know how to write this one. Yo. Okay, let me just do a line. Let me just do a line and maybe try to erase it. Good. Nice. Nice one. So here is where it's y. And y is equals to 1. So now you see why we don't have an x-intercept, because of the function doesn't come across this line. It is restricted by this line and it is up, so it doesn't touch the x-axis. Okay, another thing is that what we know is that, let me go up, I think I saw something. The x-intercept is at 2, so our x-intercept is just here. Let me draw it in red, this function. It's here 2, beautiful. Same as the turning point of the other function. Hey, I'm a bad drawer, but I have to improve my skills of drawing. Very bad. I don't know whether to start it from here or from there. Let me start it this side. There, maybe if it touches this one. Yo, this is bad. I'm struggling here. I should have started with this one. Funny shape, but I tried. Must look like it is approaching this line. I don't like it. Okay, it must look like it is approaching this line. It must show that it is approaching but not touching. Just approaching. That's our function, eh? Guys, I'll take hours and hours if I continue drawing. So here it's at where the y-intercept is the same as the y-intercept is the same as the turning point. Is that the y-axis? I'm sorry if the point looks somewhere outside. I tried, guys. Please forgive me for this one. Okay, we drew our two graphs. Beautiful. Now they say we must write down the range of f. Writing down the range of f. Oh, let me label these graphs. I forgot to label them. This one is G. This one is F. Beautiful. Our next question says it's 4.1. Is it 4.3? I think it's 4.3. But if it's not, I'll go up and check. 4.3 says we must write down the range of f of x. So the range of f of x, let's go check our graph. So here's f of x. F of x here is the maximum point. The turning point is the maximum point, is the highest point that the function can ever reach. So, and here, infinity, wherever it is, because of, I think I'm doing something wrong, because of infinity, like we don't reach it, like, yeah, infinity, wherever it goes until it reaches infinity, because of, you see, it continues. We are not restricted. If we were restricted, maybe, but we are not restricted. We are not given a restricted domain. So means that the function continues. So with that being the case, it means that y is equals to 2 is the maximum point of the function. Yes. So the range is gonna be, the range is all the y values of the function. So the range is gonna be y is less or equals to 2, because of all the coordinates are less than 2, or in interval notation, y is an element from, I also include 2 because of 2 is also in the domain, in the range, to infinity. We don't include infinity because of infinity we just approach it. No one has ever found, I believe no one has ever found infinity. Let me not just say. Now we go to 4.4. They say find the maximum value of the function, this function h of x, which is h of x. Wow, nice. This takes me time. Okay, we're supposed to get the 4.4. We're supposed to get the maximum value of h of x. H of x is defined by 3 f of x. So the maximum of f of x, we already know it is 2. So it means that the maximum of h of x is going to be 3 to the power of 2, because of already f of x is maximum. We know it here is 2, because of all values they are less than 2, or also at 2. So the maximum value is 9. So now let's do the last question. I forgot this takes me time. Okay. What transformation does the graph y is equal to fx undergo in order to obtain this. Okay, the transformation, maybe the transformation. Okay, I didn't add enough pages, so let me just do this. I'm gonna write 4.5 here. So the transformation f of x has to undergo in order to give us that function. I don't remember what that function is called. Let me go check it first. Okay, the function is y, whatever. Yeah, y. Let me just say y of x. Okay, so f of x is equals to minus 2x squared plus 2. Y is equals to 2x squared minus 2. So the transformation that f of x has to go in order to give us the transformation for f of x to be like that. Okay, let's write this function. We can see that like this new function, it's all multiplied by negative 1. So y is equals to negative of f of x. So it means f of x is reflected by because of is reflected by the y. No, the entire function changes. So it is not the y-axis. It's reflected by the x-axis because of this whole function is changed. So it's reflected by this axis. Okay, the graph of f of x is like the graph of y of x is gonna be like this. This is f of x, this is y. So that's how it is reflected. Thank you guys. If I had space, maybe I was gonna explain this further. Thank you guys for